Hello everyone and welcome back to our videos. Today we will talk about oxygen and pressurization systems. As an aircraft climbs from sea level to increasingly high altitudes, the crew and passengers move further and further from an ideal physiological condition. Two important conditions for humans to breathe at high altitudes, and they are pure oxygen or pressure. Oxygen systems at high altitudes, generally above 10,000 feet, the air is thin enough to require supplemental oxygen for humans to function normally. Modern aircraft with capability to fly at high altitudes usually have oxygen systems installed for the use of crew and passengers. Characteristics of oxygen: the oxygen is colorless, odorless, tasteless, and active chemically. Oxygen is produced commercially by liquefying air and then allowing nitrogen to boil off, leaving relatively pure oxygen. Gaseous oxygen may be also produced by electrolysis of water. How that's come: when electrical current is passed through water, it will break down into its two elements, hydrogen and oxygen. Commercial oxygen is used in welding, cutting, medical use, in hospitals and ambulances. Aviators breathing oxygen is similar to that used for commercial purposes, except that it is free of water. Sources of supplemental oxygen: in general, we have gaseous oxygen, liquid oxygen, chemical or solid oxygen, and the last one, mechanically separated oxygen. Aircraft oxygen systems employ several different sources of breathing oxygen. Among the more common ones are gaseous oxygen stored in steel cylinders, liquid oxygen and stored in dewars, and oxygen generated by certain chemicals that give off oxygen when heated. Oxygen states: the states of oxygen: 3. Gas, liquid, or solid. Gaseous oxygen, most of aircraft use it, and it is stored in steel cylinder under pressure of between 1800 and 2400 psi. The main reasons for using gaseous oxygen are ease of handling and available at most of the airports. The liquid oxygen used on military aircraft, and liquid oxygen is a pale blue, transparent liquid that will remain in its liquid state as long as it's stored at temperature below minus 181 Fahrenheit. We keep it in dewar flask that reassembles a double wall sphere having a vacuum between die walls. The vacuum prevents heat transferring into the inner container. Liquid oxygen economical of space and weight, and there is no high pressure involved in the system. The disadvantage of liquid oxygen are in handling the liquid at its extremely low temperature and burn in liquid state. Even when the oxygen state is not used, it requires periodic replenishing because of losses from the venting system. This figure shows the liquid oxygen container. What about the last one, chemical or solid oxygen? Large aircraft use solid oxygen generators as a supplemental source of oxygen to be used in the event of cabin depressurization. A solid oxygen generator consists of shaped block of chemical such as sodium chlorate encased in protective steel case. When ignited, large quantities of gaseous oxygen are released as a combustion byproduct. They are ignited either electrically or by mechanical igniter. Once they start burning, they cannot be extinguished and will continue to burn until they are exhausted. Solid oxygen candles have an almost unlimited shelf life and do not require any special storage condition. They may not be shaped as cargo aboard passenger aircraft. They can be shaped aboard cargo only aircraft and must be properly packaged, made safe from inadvertent activation, and identified properly for shipment. The last source of oxygen, the mechanically separated oxygen. A new procedure for producing oxygen is its extraction from air by a mechanical separation process. Air is drawn through a patented material called molecular sieve. As air passes through, the nitrogen and other gases are trapped in the sieve, and only the oxygen passes through. Part of the oxygen is breathed and the rest is used to purge the nitrogen from the sieve and prepare it for another cycle of filtering.